So folks, we've done all the heavy lifting for this in the previous video, which was very lengthy, but now I think we're ready to really run with these ideas. So here I have summarized all of the important formulas for the TNB frame, as well as the formulas necessary for computing curvature and torsion. So this is a handy reference for you. I don't expect you to have all of these formulas memorized, but I will point out the ones that you should have an intuitive understanding of. So I do think that we should completely understand that the unit tangent vector is computed by taking the velocity vector, which is a tangent vector, and dividing it by its magnitude. Of course, this only works if the velocity vector isn't the zero vector. So that's what we mean by the unit tangent vector. So although I don't say you should memorize this formula, you should implicitly understand that the unit tangent vector is just the derivative vector divided by its own magnitude. Similarly, I want us to know that when we go to compute the unit normal vector, one way to do so, although not always the easiest way to compute the normal vector, is to take the derivative of the tangent vector, that's what you computed in part A, and then divide it by its magnitude. So just keep in mind that a unit vector of some vector v is always just that vector divided by its own magnitude. Then, folks, I do not expect you to know this formula at all. It will be given to you if you want to use it on an exam. However, you should instinctively know that the binormal vector from that TNB frame is given by the unit tangent vector crossed with the unit normal vector. Now, how do I remember that B, the unit binormal vector, is equal to T cross N versus being the normal vector crossed with the tangent one? So this one is incorrect, but how do I remember that? An easy mnemonic device is we keep calling this thing the TNB frame, and this reminds me that if I take T crossed with N, that will give me B, and that prevents me from computing it this way. Okay. Folks, here are some formulas for curvature. The only formula for curvature that in my mind makes any sense is this one right here, and we'll discuss this in class. These other two, this is simply making the curvature, it's dividing out the velocity component. This formula right here, in my opinion, doesn't make a whole lot of sense. It's more that this is an easier way sometimes to compute curvature than either of these two calculations might be. So this is sometimes helpful for speeding up the calculation of curvature, but it does depend on the context of the problem. Likewise, I do want you to know that torsion is related to the change in the unit binormal vector, but that's all I want to say about torsion. However, here are two handy formulas for computing torsion. Both of those will work. Neither of these really, by memorizing the formula, do you get any insight into torsion, but these are rather formulas that are meant to be easier to compute if you were just strictly computing torsion than running through this litany of other things and trying to compute this expression here. So folks, moving on, it's important to remember that n is the unit tangent vector of t, and as such, it conveys how t is changing, but by that I mean it with respect to its direction. Since t is a unit vector for all t, then t can only change through a change in direction and never changing in magnitude. Okay. So folks, I'm going to leave you there, and I want you to instead consider these problems and try your best. I think it's completely fair game to ask you to compute this unit tangent vector. I think it's completely fair game to ask you to do this computation, to take their cross product and evaluate these. Then go ahead and take a look at this graph in CalcPlot 3D, so the graph of this vector value function, and use this script. So this procedure is you'll download the script just like we did for the previous script. Then you'll click the link to CalcPlot 3D, and then you'll upload the script into CalcPlot 3D. Then I want you to try these three problems here. I do think it's completely fair game to expect you to be able to do these four questions. These three are a little bit harder, but I want you to think about them, and that's what we'll talk about in class. So folks, I'm not doing a whole lot on this last page. I'm leaving you to do some of the exploring. I hope that's okay, but sometimes that's the best way to learn. All right, folks, that's all I've got for you. Thanks for your patience, and I know this was a very long pre-work, but hopefully this insight that we went through, specifically this video here, was helpful. Let me know if you have any questions.